Okay, I'm going to go over the review that we're doing in class for the second quiz of Unit 4. So the first one is graphing this inequality. Y is greater than or equal to -3. If we think about the equation y equals -3, that would be crossing our y-axis at -3. And also, at all of these points, any point along this horizontal line that you can see I'm making, all of those y values would be -3. So anywhere on this horizontal line, y is -3. Now, since the inequality has the or equal to, that tells us we're having a solid line there. So to figure out if I want to shade above or below, I need to take one of my test points. So remember, your test point is anything that is not on the line. So for example, 0, 0 here is not on the line. So we can test 0, 0. Now, so my x value is 0 and my y value is 0. So if I put 0 in for y, I have 0 is greater than or equal to -3. Well, 0 is greater than any negative number, so this would be true. That means 0, 0 is a solution to the inequality. If we were to put that point in the inequality, it would make it true. That makes it a solution. So we're going to shade everything that includes that point, 0, 0. So we would shade above. So remember, if we have an inequality, that is when we have the greater than or less than, and that's when you are shading. Okay, if you were to have an equal sign, you would not have to do your shading, you would just do your line. So the special part about inequalities is we have to see if we have a dotted or solid line and then do the shading. So number 2, we have our system. So we are going to graph both of these. And so when I'm graphing my first one, I'm just going to ignore that second one. So right now, I'm just going to look at this y is greater than 3x minus 3. Well, that 3x minus 3, that's in slope-intercept form. So our key features here, we're going to know the slope. That's the number in front of the x, so the slope is 3. And this also tells us our y-intercept. That's this number at the end here. So the y-intercept, remember, is crossing at the y-axis. So the x value is 0, and we see that the y value is -3. So the first thing I'm going to do is just plot my points like normal. Once I have my key features, I'm going to do my y-intercept first, so over 0, down 3. Then from that point, I'm going to use the slope. So 3 is the same as 3 over 1. So from the point I already have, I'm going to go up 3. So up 1, 2, 3, and then over 1. Okay, now that we have 2 points, we can connect our line, but we need to pay attention to the inequality. Since it does not have the or equal to, we are not going to have a solid line through this. We're going to have a dash, and I'm gonna cheat on mine because we know I can't draw a straight line. Okay, that is really hard to see. Let me change the color. It's a little better. Okay, so there's our first line. Now, since this is an inequality, we're going to have to shade. So we're going to pick any point that's not on the line. Well, luckily, 0, 0 is not on the line. So I'm going to test the point 0, 0. So whenever I see y, I'm going to put in 0. Whenever I see x, I'm going to put in 0. Everything else stays the same. Okay, 3 times 0 is 0. 0 minus 3 is -3. I have 0 is greater than -3. That is true. So since my test point is true, I'm going to shade to the side of the inequality that includes that test point. So my test point was over on the left here, right here. You can see that's 0, 0. So I'm going to shade everything. It's making a circle. There we go. I'm going to shade everything that includes that point. All right. Next is I have 8x minus 6y is less than or equal to 24. So I'm going to graph this inequality. I'm just going to pretend like that other one isn't there. So This is in standard form. Now, when we are in standard form, our key features are going to be the x-intercept and the y-intercept. So my x-intercept and y-intercept. Okay, when we are finding the x-intercept, that is crossing the x-axis. So I know when I'm finding my x-intercept that y has to be 0. Okay, so if I put 0 into this, and if you remember in class, when I find my key features, I like to use an equal sign. So 8x minus 6 times 0, well, 6 times 0 is 0. So 8x minus 0 is going to get me 8x equals 24. Okay, so to get x by itself, we have to undo that multiplication. So divide both sides by 8. So x is going to be 3. So this is telling me I am crossing my x-axis at 3. That point is 3, 0. So I'm going to go over 3 on my x-axis. Then I'm going to find the y-intercept. I'm going to erase that. It makes it hard to see. Okay, the y-intercept crosses the y-axis, so x is 0. Eight times 0 is 0. 0 minus 6y gives you negative 6y is less than or equal to 24. And I just said earlier that I like to use an equal sign there. Okay, so my y is going to be simple math, negative 4. So that means my y-intercept is at 0, negative 4. So I'm crossing the y-axis at negative 4. 1, 2, 3, 4. Okay, I talked about this a lot in class. Please remember that your x and y-intercept, those are different points. Do not combine those into one point. Okay, one crosses the x-axis and one crosses the y-axis. Now I can connect these. So I'm going to look at my sign there. I have an or equal to, so we're going to connect these with a solid line. And I'm going to use this again. Okay. All right, so now that I have this, I need to do my shading. So I have, we pick a test point. Well, 0, 0 again is not on the line, so I'm going to test 0, 0 again. And luckily with standard form, everything on that left side is going to get canceled out when I put in 0. So I have 0 is less than or equal to 24. That is true all day long. So I'm going to shade to include the origin, 0, 0. So I'm going to shade above the purple line. Okay, so again, we're just kind of pretending like that other one isn't there when I'm working on my second one. Okay, and we have a super big overlap here. Hopefully you can see that the overlap here is right here, and it's going to go all the way down. Okay, so there is our overlap. Anything in this section is going to give us solutions to our system. Okay. All right, given the system to the right, are the following points solutions? So starting with 0, 0, my favorite point ever. Well, we need to ask ourselves, is 0, 0 in the double overlap? And it is. Okay, it's included in the red and the blue, so yes. Negative 6, negative 9. So I'm going to go over 1, 2, 3, 4, 5, 6 to the left, and then down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, this falls on a dotted line. If anything falls on the dotted line, you know right away that it is a no. Okay, any points on a dotted line are not solutions. The next one, 4, 2, 1, 2, 3, 4, up 2. That is only in the blue section. That only works for one of the inequalities. It doesn't work for both. In order for something to be a solution to a system, it has to work for both. So over 3, 0, we have the same thing. Only works for one. All right, 9, negative 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Down 3. Oh, that's not a solution to either one, so that's a big old no. Okay, so just finding points that are in that double shaded section. All right, the word problem. We love word problems. Suppose you have a new job, a job at the new Whataburger making $12 per hour. You also have a babysitting job that pays $6 per hour. You want to earn at least $60 per week, but would also like to work no more than 15 hours per week. So what we're gonna try and do is figure out how many hours we can work at each job. So it doesn't do a good job describing that, what you're looking for, but we want to know how many hours we can work at both jobs, to mix it up and make at least $60 but work less than 15 hours. So the two things. Our first one, we want to know number of hours at Whataburger. And so that would mean Y is the number of hours babysitting. Okay, so write a system of two inequalities. So we can't have an equal sign. We have to somehow have less than or greater than, or less than or equal to, or greater than or equal to. And we need to write a system, so we need two of them. So whenever we are dealing with a system, we start by looking for our totals. Well, we want to earn at least $60 per week, but work no more than 15. So our totals are going to be 15 hours total, but then 16 or $60 per week. Okay, so if we're looking at our hours, well, our hours are made up of how many we work at Whataburger and how many you're working at babysitting. So you just need to combine those two. So you would take x plus y, and if we want to work no more, x plus y is the number of hours we're working. We need to be working less than or equal to 15, because no more means you can work 15, but you want to work less than. You can't work more than. So then our other one is dealing with 60. Well, that's $60. So I'm going to take how much I'm making at Whataburger, which is 12, multiply that by how many hours at Whataburger, and add the babysitting, how much you're making at babysitting times how much. And you want at least $60. So this right here, this 12x plus 6y, this is what you're making. And we want that to be greater than or equal to 60. At least is inclusive, so it can be or equal to. So there's our two inequalities, and we are going to graph the system. Well, if I'm graphing the system, I'm going to rewrite these down here so I can write out my key features. Okay, these are both in standard form. So let's start by looking at this x plus y is less than or equal to 15. Well, if I want to find my x-intercept, I need to make y equal to 0. Well, if y is 0, that means x is 15. That y goes away. So my x-intercept is 15, 0. My y-intercept, I'm going to make x equal to 0. And we get the same thing there. If x goes away, I just have y is 15. So boom, there's that. Okay, before I label my x and y axis, I want to find both my x and y intercepts so that I make sure I have all the numbers I need on those axes. So let's go ahead and go over here. Again, this is in standard form, so I'm going to find my x-intercept. I'm going to make y 0. This one's a little more complicated, so 12x plus 6 times 0. equals 60. And remember, this step right here is one that you can skip. You can go ahead and go straight to 12x equals 60 if you're able to visualize the fact that that y term goes away. If you need to write out that first step, that's more than okay as well. Okay, so to get x by itself, we need to divide both sides by 12. So x is going to be 5. And let's see. That means my x-intercept is 5, 0. And then we have the y-intercept. X is going to be 0. So again, this is a step that you might be able to skip. So I have 6y equals 60. If you can jump straight to 6y equals 60, that's okay with me. So y is 10. We get that by dividing both sides by 6. So we get 0, 10. So if I look at my x-intercepts, I know the highest x value I need to get to is 15. On the y's, the same thing, I need to get to 15. So we should be good to go by ones on here. So I'm going to label. I said x is the number of hours at Whataburger, so on my x-axis, I'm going to put Whataburger hours. And I'm going to label these by ones. Okay. So then y we said is babysitting hours, so I'm going to label my y-axis. And 1. Okay. So let's start with graphing that x plus y is less than or equal to 15. So I'm going to put a point on the x-axis at 15 and on the y-axis at 15. Remember, please, please, please do not combine your x and y intercepts. Do not make them one point. They are two separate points. So once we connect those, we should have something like this. And I do suggest using some type of straight edge. Okay, so now we need to figure out what to shade. Well, guess which point I'm going to use. Bet you didn't see it coming. 0, 0. It's not on the line. If I have 0 plus 0 is less than or equal to 15, 0 is less than or equal to 15. That is true all day long. 0 is less than 15. So when I shade, I'm going to pick the right color. We have to match. I'm going to include that 0, 0. Oh, of course, I went outside the lines. Ignore that part. All right. So that's my first one. Now I'm going to graph my second one. I'm just going to pretend like that other one doesn't exist for now. I'm going to take this information, I'm going to put it on my graph. So my x-intercept is 5, so I'm going to go over 5 on my x-axis, and then up 10 on my y, and connect those. This is kind of hard to see. Let's make it a different color. There we go. Okay. So there's my new line, and again, I'm going to have to shade. So let's test 0, 0. Nice thing about standard form, I'm going to have 0 is greater than or equal to 60. That is not true. So if 0, 0 is right here, I need to shade on the other side of that line. So we're going to shade over here, and this is going to take me forever, so bear with me. Okay, so hopefully you can see where we have that double overlap, okay, right in this area here. Okay, so you could pick any point from this area and you would have a solution to your system. So two possible solutions, well, you have lots of options. You could pick here, you could pick here, or here, or here. So you have lots of varieties on what hours you can work. So let's say we pick this one, 6, 6. Well, that one's fairly easy to interpret since it's the same exact number. It doesn't even matter. So 6 hours at Whataburger, 6 hours of babysitting. So 6 hours at each. Now, if you were to pick a number that didn't line up like that, so let's say this 310. Well, if you pick 310, then you need to go look back at what you defined your variables as. We said x is the number of hours at Whataburger. So if our x value is 3, that means 3 hours at Whataburger and 10 hours babysitting. Okay, so again, lots and lots of options in that area there. That is it for the review that we are doing in class.